Okay, the recording has started. So today we're going to do chapter. There are some short chapters. So last time we did number system and data link. So today we'll do Ethernet switching and network layer. So in Ethernet switching, we continue with data link layer, how the switch will forward packet, how we frames, how we switch will control the flow. For example, PC1 send something to PC2. I'm going to open my packet tracer here. I'm opening up my packet tracer. And so what we did, we are still busy with the OSI and TCP IP model. We know that we use them to classify. So when I have a network, how am I going to classify everything? With TCP IP, we have 4 layers. But with OSI, we have 7 layers. Physical layer, data link layer for layer 2. Layer 3 is network layer. Layer 4 is transport. Layer 5 is session. Layer 6 is presentation. Layer 7 is application. So everything we are doing now is to go to each layer. So last time we did for layer 1, the physical layer, we did check anything related to a cabling is allocated to a physical layer. Then we went to a data link layer where we did check that the switch is sorry, my mouse is not working properly. Let me allow someone to log on. Who want to admit? This, yeah. And yeah, so we did study the physical layer already, and we studied also the data link. And we checked that in the data link, it will switch the equipment that we find in the data link is the switch. Anything related to a switch is classified in the data link layer. At the later stage, we'll check that anything related to layer 3 in the network layer, anything related to the router will get allocated to the network layer. So we have our router, layer 3. Sorry, I think my mouse is... Anything related to a switch is data link layer, MAC address, frames. For the router, it's mostly IP address, subnet mask. And anything related to cabling is layer 1. What is that packet trace of mine? It's still loading. Okay, let me wait for my packet tracer to load. That's mouse of mine is not working. It seems like my mouse is not working. Okay, so yeah. And I don't have another mouse. It's only one. Okay, let me check. Oh, sorry, guys. I'm trying to fix that mouse of mine. So anything related to the switch. So today we'll continue with the switch. We'll continue a bit with the switch. That's why this chapter, my mouse, this chapter is Ethernet switching. So in this chapter, oh no, this one. Sorry, today my mouse is giving issues. So in this chapter, we'll see how we switch forward the frames. So a layer 2 Ethernet switch makes, so let me go back here. So Ethernet operates at the data link and physical layer. Ethernet standard define both layer 2 protocol and layer 1. Ethernet uses LCC and MAC address. The Ethernet frames. Okay, so when you have a frames, what do we find in a frame? It's here. When you have a MAC address, always, we're going to check them now. When you have a MAC address, how it's organized. So please remember, this training is the same CCNA training all over the world. You go to Canada, to America, to Europe, to Africa, it's the same training. That's why it's the same certificate issued by Cisco first. Everywhere you go in this world, it's valid. So please take it seriously, study well for your own knowledge. You don't understand something, post in the group or contact me and we'll help you. So the switch will make forwarding decision based on layer 2 MAC address. Sorry for my mouse, it seems like it's faulty today. So the switch, when a PC1 want to communicate with PC2, we know that all PCs are connected to a switch. So when PC1 wants to communicate with PC2, the switch will receive the MAC address, the frame, and the data, the frame. And inside the frame, I have destination MAC address. And the switch will check the destination MAC address, check in the MAC address table, then we'll decide. Let me try to make something very simple for you. Okay, that packet tracer is here now. So I'm going to put a switch. So anything related to a switch is layer 2. We deal with MAC addresses. Okay. So don't forget, not using that yours. Yeah. So anything related to layer 2 data link layer, anything related to a switch, we classify them there. The MAC address or the physical address, it never change. So this is, for example, a switch. You have a switch here. Then you have some PCs. This is a PC, this is a laptop, this is another PC. And we know that all the PCs they are connected to the switch. So when you go in a company, anywhere, if you have a PC, in the background, the network cable is connected to the switch. So now, PC1, this guy here, PC1 want to communicate with PC3 down here. So PC1 want to communicate with PC3. So for example, you want to send an email. When you press enter, your data, let me put something like that, fill, I put green, for example. Oh, it's not nice. Yeah. No, it's not nice. Put red. Yeah. Okay. Yeah, something like that. Delete, delete. So when you press enter or send, your message will come to the switch. And what is in that message? That message is the frame. The frame. And inside that frame, I'm going to show you, we have some information there. I'm going to show you an example of a frame. Yeah, this is a frame. That data in red is called a frame, and this is how it is. So inside the frame, you have your normal data, your email, your content. Then the layer 2 will add extra info. That's why we call this guy a frame. Why? Because in your data, we did add layer 2 information. Then the whole package is called now a frame. Your email is here. Now in that frame, it shows your source MAC address. Where do you come from? The MAC address of PC1. Where this message is going to, the destination MAC address. This is the big question here. Destination MAC address. So the switch will check, where do you want to go? Destination MAC address. We go back to our packet tracer. So the frame here now will read the destination MAC address. Destination MAC address. It will open the frame and go there, destination MAC address. How the switch will find that destination MAC address? So inside that switch, we have something called a MAC address table, a register. We tap enable. So it's like you're a security guy and a student. So we switch to the security guy. And the student comes, want to go to university. You say, hi, sir. Please, I want to go to engineering building. The security guy will check in his table. We call it MAC address table. MAC address. It will check on his list. Say, okay, on my list, I can see that engineering building is on the left, on the east of the university. Yellow building. So go to my left side, you'll see a yellow building. It's there. So the security guy knows about the engineering building because it's in his list, MAC address table. So inside the switch, as soon as you're connected to a switch, your MAC address is listed on the port. You see, if you connect to a switch automatically, your MAC address is registered to that interface you're connected. You see. So let's check what is in the MAC address table. Let's type show MAC address. In that MAC address table, you have, if you created some VLAN, will be here. It's something we'll do later. And all the MAC addresses will be listed here. For now, we don't have any traffic. It doesn't show, but in real life, automatically it's populated. Let us generate some traffic. I'm going to open here. Let me check if it's okay. When I open, I'm going to add an IP address to a PC, for example. It's just an example, 192.168.1.2. Subnet mask, I just click in, it's fine. This guy, I'll add an IP address, 192.168.1.3. Subnet mask, I leave it. PC3, I add 192.168.1.4 MAC address. So the subnet mask, I can put PC1 here and I add the IP address. PC1 is here. This is PC2. And this is PC3. Make it nice like that. Yeah. So if PC1 want to communicate with PC3, let me ping. Ping, it's like you want to dial someone number to communicate with. That's why we say ping. So I'm going to ping PC3 IP address. Or I take my cell phone and I'm dialing PC3 number 192.168.1.4. You press enter. If you see this thing, it means it's successful. 0% loss. It means I can communicate with PC4. Let me check for PC2 if I can communicate with PC2. I can also communicate with PC2. Now, let me go check in my MAC address table here. Open it. Press enter, enter. Show MAC address table. Now I can see some data. You can see that I'm the switch. And on my port 1, I have a MAC address of PC1. On port 2, I have a MAC address of PC2. On port 3, I have MAC address of PC3. This is what is inside a switch. MAC addresses only. At a later stage, we can configure other stuff like VLANs, put some security, put some stuff. So this is a frame. PC1 want to communicate with PC3. The frame will reach at the switch. The switch will take that, open it to check the destination MAC address. I'm going to copy it. Let me see if it's going to work. Okay, I copy everything, copy. And I come to MAC address table here, press enter, I paste. So this is the MAC address in the switch. So when the switch will open the frame, it will check the MAC address how should I copy this? Okay, I come here and I grab this and I grab this, for example. I just grab the MAC address here. Okay, let me grab everything, it's fine. Copy, and destination MAC address, it's this guy. Oh, you see. Okay, anyway, no, I'm going to delete for this. I'm going to delete. Yeah. So this one is source. Source. And this one will be destination. Okay. So when the frame arrives at the switch will open it, will go through, see source MAC address. Okay, you come from PC1, and where do you want to go? You want to go to a destination. How did I write destination here? Destination. And your destination is this MAC address. Now the switch will check in the MAC address. Okay, this MAC address, is it in my routing? Is it in my MAC address table? Yes. And it's on my port 3. Then the switch will send here. So any packet, when anyone want to send something, it comes to a switch. The switch will check the MAC address, the destination MAC address in the addressing table. If he knows it, okay, I know about that MAC address, and it's on my port 3. So I'm going to forward your data on port 3. You see port 3 here, port 3. So the switch can forward because the MAC address is known in the MAC address table. If the switch doesn't know the MAC address table, it's going to send to all the ports except the port where it comes from. So this is how a switch works. Inside, I have MAC addresses, and yeah. So have a look quickly, then we continue. If you have a question, let me check here. What is the, yeah. Yeah. Can I remove this one also? I can remove this one also. Yeah, so this is how it works. All PCs in the company are connected to the switch, and inside the switch, we have a table called MAC address table, where all the ports are listed with MAC addresses. If you want to communicate with someone, the switch will check in the MAC address. If it knows the port, it will forward the data there. If it doesn't know, you want to broadcast to all the ports except where it comes from. Okay, so this is an example of frame. What else? Let's go back to the summary. And so now we know the frame. So in the frame, you have many things inside there. Okay, it's exactly what I explained to you. So let's go step by step and check what I can give you. Else, let me go to NetAcad. NetAcad, it's fine. So Ethernet switching, if you go here, so here what you should know, what a frame is, and the component in a frame, what a MAC address is. We're going to study a bit. When you have a MAC address, what does it mean? You should know what the MAC address table is and the forwarding methods. So normally we have two. So when the switch will receive your frame, we have two types of forwarding. The first one is straightforward. It means it's going to check the destination MAC address. When he finds it, it will send automatically. It's quicker. The other one is called stored and forward. It means what? It's going to check all the fields in the frame. If everything is okay, the frame is not damaged, then it can forward the packet. We're going to check that now, no worries. So with forwarding method, we have two Ethernet frames. So we did study the physical layer. We did study also the data link layer, and we saw that in data link layer, you have a LLC and the MAC address. The main one is the MAC address. And yeah, MAC address is responsible for encapsulation media. Who want to log on? Admin. So yes, we did study layer 1, physical layer, layer 2, data link layer. It will switch that is here. And the switch will deal with MAC address. And okay. Okay. And the frame, this is what the big frame is. Your normal email is here, and at the layer 2, we'll add extra info. Each field is explained. We will explain each of them then. At a later stage, we have a software called Wireshark. We can download to grab traffic. And from there, we're going to check MAC address, and you have the MAC addresses. I'll show you a bit later. If you have your MAC address, what is inside? What is inside a MAC address? So inside the MAC address, for example, if I want to view my own MAC address, I type what? CMD, I press enter. Then I type ipconfig space /all, and I press enter. And because I'm using my Wi-Fi, I'm not using a network cable. If you use a network cable, you come to, okay, because I'm not using a network cable, I cannot see any IP addresses. I'm using my Wi-Fi. That's why my Wi-Fi network cable is displaying all this info. I have my IPv4 or the logical address. This one is for layer 3. And I have my physical layer or my MAC address. So you see that number D4 F3 2D. Remember, we did that on Saturday. So the MAC address deals with hexadecimal numbers. Normal IP addresses, it's numbers that we will understand, but the physical layer, the MAC address is hexadecimal numbers. So MAC address and hexadecimal, we have 12 hexadecimal value. Let me see if we have, we say 12 hexadecimal value. Let's check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. See? So it's 12, and each digit is an hexadecimal number. You know your table, huh? You start from 1 to 9, after that A, B, C, D, E, F. So now here, we'll try to explain what is the meaning of that. So we have 1, 2, 3, 4, 5, 6. And inside, we have, for example, okay, let me copy this one for you. You don't need to memorize, it's just to understand, to have an idea, that's all. If you copy this, I'm going to copy this, and I put in here. And I put it away. Okay, let me put it down here. MAC address. If I take my MAC address and I put it down here, yeah, we're going to check together. Put in blue. Is blue nice? No. Black? No. No. Red. Okay, let's put red. So I'm going to show you here. This one is here, 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 and this one is here. So remember a byte, if you have 8 bits, 1, 2, 3, 4, 5, 6, 7, 8, if you group it, we call it a byte. So this one is a byte. So D is the hexadecimal number here. 6 is the hexadecimal number here. So if you take 6 and you go in your table, you will see that. What is that table of ours? Yeah, this is our table. I copy it. And I paste it down here for us. Center. And all of this stuff. Yeah, and I call it MAC addresses. MAC addresses. So if you take 6, if you come in our table, 6 is what? 0, 1, 1, 0. So normally you put the real value of 6 here. So it's four digits. So 6 here is an hexadecimal number, 4 digit. D is also an hexadecimal number, is 4 digit. So if you take on top, if you count all the ones, 4 plus 4 plus 4 plus 4 plus 4 is 128. To 128 stuff. So this is how a MAC address is. If you see such MAC address, this is how it's organized. Now, we have 2 groups in that MAC address. We have the first 3 bytes is called OUI, no, OUI, yes, organization, blah, blah. Okay, and this one. So let's say I'm Samsung and I'm manufacturing some cell phones, and all the IDs, I'm Samsung, this part will identify me as Samsung. Now, if I'm selling to, let's say, CPUT, I put this MAC address for CPUT. So the vendor assigned. So when you have a MAC address, we cut in 2. The first one is organizationally, okay, OUI, and the second part is for the vendor. You don't need to memorize. It's just to have an idea. So I have my 6 groups. This is my MAC address. Or is it? It's here. 6 blocks. The first block, so as you see, and this one I put in green. So the first three is OUI, and the last three for vendor side. Okay, it's just some info. As a network engineer, it's good to know. Okay, anything else that's we can see here? It's what I explained in the packet tracer. When you want to communicate with someone, the frame will reach the switch. It will check the destination MAC address and check the MAC address table and see. Now we have something called unicast. If I'm talking to you only, let's say I'm talking to John Kalanga, for example, only we say our communication is unicast, is one-to-one. So unicast communication is one-to-one. Unicast. If I want to communicate to the ladies only in our group, we say it's multicast. I'm talking to a specific group in our team, or to male only. If I want to communicate to everyone, you say I broadcast. So these three things, I think it was in chapter 1. It was in, I think in chapter 1, I'm going to show you. If you go to chapter 1, you'll see, is it chapter 1? Let's check. Chapter 1, no. No, not chapter 1. Let's go to chapter 2. Protocols and models. Protocols, the rules. Chapter 2, yes. So please read this slide, and we continue. So in IT, for communication, we have unicast communication, one-to-one down here. I'm here, I communicate to only this guy only. You say, I'm unicasting you. I'm communicating with one. Multicast, I have my group here, but I communicate with a specific people. With ladies only, for example, I say I'm multicasting. If I communicate to everyone, like now, I'm talking to everyone. I'm broadcasting. Yeah? I'm broadcasting. So this one is also important to know. In your next assignment, I will ask such questions also. This is also an example. Unicast, multicast, broadcast. Job interview, we can ask you, what do you know about unicast, multicast, and broadcast? So you should know. Okay, we continue. This one was chapter 2. We're in chapter 7. So what you need to know here is unicast, broadcast. And if you see a frame, if everything is FFFF, it means it's a broadcast frame. It means this guy wants to send a message to everyone. So when it will read destination MAC address FFFFF. Okay. It means this message for everyone connected to my port, I send to everyone. So check this one, very important also. And you see here in the frame, the destination MAC is FFF. Okay, it's a broadcast. Let me send to everyone. Okay, we continue. If you see a MAC address with destination 01005E, it means it's a multicast. You don't need to memorize, just to have an idea. That's all. Yeah, I think that's all. MAC address table, it's what I did explain in the demo. It's exactly the same thing. You have a video, will explain exactly the same thing. You can also watch that video. And how the speed, the switch will forward. We have store and forward. It means when the switch will receive a frame, it's going to double check all the fields, all the components. If everything is good, then it can send. Start through, it will check maybe only the destination MAC address and forward. It's quicker, but this one is a bit slower. You can also quickly check and continue. Okay. Then we'll try to explain more and give more explanation and all this stuff. Duplex, we know the difference between half duplex. Only one end of the connection can send at a time. Full duplex, both ends of the connection can send and receive simultaneously. So you should know the difference between half duplex and full duplex. So you see half duplex. So if you have a switch, one port you configured full duplex, the other one you configure half duplex, you'll have issues of communications. They should either both half duplex or full duplex. But nowadays, everything is by default full duplex. Okay, that's all for this chapter. It's about the switch and how the switch will manage packet frames. And the MAC address table, you know the command. And to view a MAC address, show MAC address table. If it is no traffic, it's empty. I'm going to generate traffic again. Command prompt. Okay, show MAC address table, and I have traffic here. So after you tap show MAC address table, if I tap question mark, I can add a lot of stuff also, like interfaces, question mark. Okay, I can press enter. Okay, anyway, interface FA02. We'll do that in labs. For example, if you want to view the MAC address of port 2, I want to check which one is connected to port 2. Then you tap only show MAC address, interface, and the port 2. Then it say, okay, this is MAC address of port 2. Okay, that's all for chapter 7, Ethernet switching, how the switch will manage, how the switch works, the speed, cut through, and all this stuff. Now we go quickly. These chapters are quite short. That's why I do two. So we did the physical layer, anything related to cabling. We did data link, anything relating to a switch. Now the network layer is anything related to the router. So if you have such design, I'm going to delete all this stuff. Delete this. And you add a router. So layer 1, all the end devices, cabling and what. Layer 2, the switch. Layer 3, the router. So what are we going to find there? We'll find the IP addresses or logical address. Let's check. Network layer. I'll make it very simple for you. I go, let me see here. Let me go up. Network layer. Okay, so here, it's something we'll do a lot. So I'll make it very simple for now. We have IPv4 packet. How we create South African ID, for example, it starts with your date of birth and what. So for the PCs, we have two types of IP addresses, IPv4 and IPv6. So we study them on this training. Let me make it very simple for you. So now we are at layer 3, the network layer, where we deal with IPv4 and IPv6. So also remember, when your data is here, the content of your email, when you press enter, when it reach the transport layer, we call it segment, because the transport layer will add some stuff on the data. When it reach the network layer, we call it packet. We call it a packet. So you have your normal data, your normal data, the segment, and see at the transport layer, I have my normal email. The transport layer will add some stuff. Then it will reach my layer, add IP addresses. At the network layer, we call it packet. I add extra stuff. Okay, all this stuff you can read. If you don't understand, let me know, but it's not too much important. What I want to show you, if you open an IPv4 packet, you will see a lot of stuff inside. Source IP, where this packet comes from, destination IP, and other stuff. You don't need to memorize them. We will explain each section, what version is, what time to leave is, what. We will explain step by step, all of them here. Okay, we have a video that will do some demo. At a later stage, we'll download Wireshark, we'll install it, and we'll check how it works. Then we'll also have IPv6 packets. We created IPv6 because IPv4 is almost finished, and we have more devices coming. So we need to assign them more addresses. So because IPv4 is finished, we created IPv6. This is the header of IPv6. And in each section, we will explain each of them slowly here. We'll also have a video with Wireshark. So it's like with the traffic cops. We hide someone on the highway and we have the machine to check the traffic. It's the same thing. We're going to capture some traffic. We're going to open and we'll see what is inside it. So the same thing, if a router receives a packet, it will check where do you want to send your packet. If it's in the table, so this time it's called a routing table. So for the switch, it was a MAC address table. For the router, it's what we call a routing table. So in that routing table, we'll do it a lot. For now, it's just to show you how it works. If PC1 want to communicate with someone else, your packet will reach the router, and the router will check the destination IP. If it's on my routing table, then I know where to forward your packet. That's all, nothing else. So we'll have time to study properly when we do the labs. So if you have a small network and these both PCs, they belong. So if you have a router, each port is a network or a classroom. So if two PCs will belong to the same classroom, it's easier to forward. It's simple. There is no big deal. But if it's somewhere else, then it's a big deal now. So anything else, we'll do it. I did explain to you what a default gateway is. Where in your classroom. Yeah, okay. I think we did that already. Okay, all these I'll explain a bit better via a lab. I'll explain via a lab. Let me check what I can explain to you. There is a video, yeah. So let's take this example for router 1 is here, and PC1 is here. And PC1 want to communicate with PC2. When PC1 will send the packet, it will reach router 1, and router 1 will check the destination IP address. If he knows it, it will forward. If he doesn't know it, he will decide. So what is inside a router? We have also a table called a routing table. To view it, you tap show IP route, and it will list all the networks the router knows about. So we'll do that for 4 months, so no worries. It will list, each direction is listed here. And in front of each direction, we have a letter. And each letter has a meaning. If it's O, you come here, it means This route has been added by OSPF. It's like if a security guy has his list and all the information come from Department of Education, Department of IT, Department of Medical Science. So the security guy will know that, okay, if you want to go to medical science, I know about it. It has been given to me by the Department of Science. So each route here, each network has been added here by who? If you see S, it means it's static, manually added. If it's O, it has been added via OSPF. If it's C, if it's L, each letter has a meaning that is here. We'll do it for 4 months. So from now, just have a look. That's all for this chapter. We're going to manage a lot IPv4 and IPv6. We'll open a router and we'll see the different routes. So we'll have time to do all these things, no worries. That's all for this chapter. We'll have time to with the labs, I'll explain more. I'll come back. So, okay, guys, revisions, this, and this. For example, if you see C, this network, see, it's directly connected. C, it means I know about this route because it's directly connected. C, it means directly connected. L is the IP address of the interface. If you see L, the IP address of the interface. If you see C, it means this network, I know about it in my routing table because it's directly connected to myself. If it's S, it means it has been manually added. If it's O, if it's D, all the legend is here. So have a look on this, and I will continue, and we finish. Who is joining now that we are done? Yeah, so this is something, that's why this first part of networking is called introduction. We try to give you a bit of information there and there. The second part, we'll take each device and study properly. We take the router. That's why I need to buy a router, and we're going to study it properly inside how it works. In the switch also. That's what we do in IT companies, Vodacom, MTN, when we send router to the clients, it's exactly the same thing. That's why when we say I study CCNA, okay, it means you're good, come to us. Because it's a lot of information and good information, internationally well recognized. Okay, guys, 7, we're switching, and chapter 8, a bit of routing. Then on Wednesday, we'll try to do basic router configurations. ARP, it's 10 minutes quickly. I'll make it simple for you. And the same configs we did for the switch, we'll do the same for the router, and we'll come back again for chapter 8. Like the host name, the 3 password, message of the day, the banner, how to encrypt all the password, the same thing. We'll do that on Wednesday. So normally by end of this month, we are done with the theory. Then we'll do the packet tracer, the labs. The labs. Always packet tracer will do maybe 5 or 6 of them. So on V26, don't forget V26, it's where we'll meet and we'll go through everything we studied in theory. We take a switch, we configure all the basic configs, host name, the 3 password, message of the day, encryption, and what. We'll take the router. So if you're struggling, there we'll fix it on V26. After that, there is something called the physical mode that I'll show you. So I will show you also on that day. So with 26 will take 2 hours or 3 hours. So please eat well, bring some snacks. I think Scalabrini will offer us again some nice biscuit and tea. Yeah. Also on that date, we'll do this. I'll show you how to do, and we play around. It's exactly the same thing. So if you have a packet tracer and you want to clean up and to restart from scratch, you go to File, Reset Activity. It will clean up everything you did. It will be blank. You see? It will erase all progress and start. So if I click Reset Activity, you see now everything has been cleaned up. So I'll show you, for example, this one. It's like you're in a lab, a physical lab, with your PCs, your switch, your routers. And Mr. Max will give you an assignment. You see here on top here. It's okay, guys. I need 2 groups. Group A, you take a PC and a switch. Group B, you take a PC and a switch, and you do that demo. You do that config. So it's simple. You take this PC, you put it here. You take another PC, you put it here. You zoom in. You check the names. You see PC A is here, PC B is there. It's off. You power on. You power on. Then we need 2 switches. You can go back. Switch 1 is here. Switch 2 on top. See, you zoom in to check if the names are correct. Yes. Now we need to connect PC A to the switch. To connect a PC to a switch, what type of cable? If you bring your mouse, it will show console cable, the blue one, straight through. You see, so we use a straight through. And we say pass Ethernet, you click here, and on the switch, we say port F06. If it's too small, you zoom in. Switch 1 is here, F06. You see, and you put it there. You bring back. I need to connect switch 1 and switch 2. To connect 2 switches, we use a cross cable. So bring your mouse, straight, serial, and crossover cable is this one. You grab one, you zoom in. So I'll teach you on the 26. Port F1, F1. You bring F1 here. F1, you click. F1 here. Then we say I must connect switch 2 to PCB. Straight cable. I zoom in a bit. I put it in. And port 18. I zoom in a bit. 18 is here. You click on it. That's all. You see. That's my design. And you can check here, down here. I have already 38%. It means my cabling are correct. Now, I need to log on a switch and do all these things. Host name, V3 password, encrypting all this password, and what. The same thing we did before for your assignment number 3 that you need to send to me. The same thing we'll do here. So this one we call it the physical mode. It's like you are in a room and you do your stuff. We'll do that on the 26th also. Thank you very much, guys. Any questions? Any questions? Okay, so if no questions, then we are done for today. Christina, question, yes.
Yes, teacher, I want to know about the frame, that red frame. It's coming for what?
Where?
The frame is a red one. I don't know if did you press one place and then the frame will come, or you make it.
So if I'm here PCA and I want to send a message to PCB, my message, I just put in red to show you that it's my data, my email that is leaving my PC to go to the switch. So is it what you're asking?
Yes.
Yeah. So when you create an email and you press enter, your data will leave your PC and go to a switch, then a router. So it's myself, I just put in red to show you that it's a data that is leaving to go somewhere. That's all.
Okay.
So please don't miss Friday 26th. It's where I'll double check everyone if everyone knows how to do what. You can ask any questions and all this stuff. Any other questions? Okay, if no question for now, and you have question later, you post in the group or you can post to me with no problem, and I will assist you. Thank you very much, guys. Have a good evening, and we meet again on Wednesday, 6:30, where we'll do something else also. Have a good evening and keep well.